We're going to be doing the R3s from the rationals part of the review. And there's a lot of factoring. And then recognizing when you have holes. If you haven't already put in your horizontal and vertical asymptotes, you should do that now. Because when you graph this thing, that'll be one of the most crucial parts is did you put the horizontal and vertical asymptotes in the right spots? And if you're like, where the heck is the horizontal? Well, you should be able to use the 1000 trick in order to see that. And I shouldn't call it a trick. It's actually kind of like doing a limit. So it's a good way to test and see where is the horizontal asymptote in the long run. Long run meaning like 1000 for x. So after this and this cancel, I like to rewrite my new equation, x plus 6 over x plus 1. And you have a hole at positive 6, comma, and then you stick it in your resulting function here, and you get 12 over 7. Who had 12 sevenths as the other part of their hole? Good job. Then vertical asymptote is whatever makes the bottom 0 that wasn't a hole. That right there, x equals -1 would make the bottom 0. So that's where the asymptote is. Horizontal asymptote. You go way to the right and you see if it leveled off. If you put in 1000 and you get 1000, it didn't level off. But we put in 1000 here and we get 1006, which is pretty much 1000. Over 1001, which is pretty much 1000. So y equals about 1. So as I look at my graph, it would have an asymptote here and here, and it would have a hole at 6 comma, well, 12 sevenths is pretty much 2. So 6 comma 2. And we'll talk later. I'm noting that you're here at 10:01, so we'll figure out how long you've been absent later. All right. And now we're going to try to figure out a few more points. This is the hardest part. Because honestly, if you can't do these, you're going to bomb the whole test. Okay, so the hardest part is, can you find some other points then to go through? Because just from one spot, I can't tell what this graph looks like. I need some more points. So I personally would just make an XY chart. I would put that hole on my chart, 6 12 sevenths, and make a designation that it's a hole. And then I would get points around the asymptote. Because see, x equals -1 was a key moment. And if I had spots to the left of that and to the right of that, that would be good. So like putting in -2 would be smart. And putting in 0 would be smart. Just on either side of the asymptote. All right, so if I put in -2 into this equation right here, if I put -2 in there, I end up with 4 over -1, which makes -4. The fact that it worked out to an integer, like a nice whole number, that was a sign that I probably did it right. -2, -4 is like there-ish. Maybe I should use red for my graph points. Okay. I should probably be a little lower to keep my scale. Probably more like that. Okay. And then when I put in 0 into this equation, I got 6 over 1, which is 6. And again, the fact that it came out to a whole number means I was probably onto something. So over 0 and up 6 is like right there-ish. Now, is that enough points? It's maybe enough for up here, because I can see this will use asymptotic behavior. It'll get closer and closer to the asymptotes. These will have to connect, and this will get closer and closer to the asymptotes, and that's probably good enough. For down here, 1 point is probably not enough. So I should probably find at least one more point here. Like maybe I should go out to like -5 or something. Now I'm going to go look at my graph and see what would happen if I put in -5. It doesn't have to be -5, but -5 plus 6 is 1 over -5 plus 1 is -4. So 1 over -4 is -1/4. It's basically right about there. And now I've got enough points. I can go through this and then go that way, and then asymptotic behavior means closer and closer to this asymptote here. And I'd say that is one of the hardest questions. Do you remember that on the test for this, we had 2 holes in the graph? A ton of kids only had 1 hole. On the problem we just did, there was only 1 hole. But let me remind you how there's a sneaky way to build in another hole into a problem like this. Do you get if there was an X on the top and an X on the bottom? That would create a hole at 0. Why? Well, because these would cancel. And what makes that part 0 is if X is 0. There'd be a hole at X is 0 if there was another X on top and an X on the bottom. And if there was another hole at X equaled 0, then that would actually have been a hole. I'm not saying there was. I'm saying that on the last time you had the test, on both versions of the test, there was a problem that had 2 holes in it. So I don't even know. I haven't even looked at the cumulative, but I would guess that there'd be another one like that where there's a couple holes. So watch out for that extra like X that could create a hole. I'm not even sure that that's on there. I'm telling you, it's really common for kids to see the hole when it's like this and it's really obvious. Oh, it made a hole at X equals 6, but not see the hole when there's like a 2X and a 3X or something, and they're like, oh, those won't cancel. Yes, they will. These would also cancel and create a hole at 0. 0 comma something. Yes?
Why is the horizontal asymptote 0? Wouldn't it be 1?
All right. The horizontal asymptote is at 1. Oh, crap. Look at that. It is at 1, and yet I put it at 0. I'm just going to cheat and move it up 1. Because everything else was fine. Good catch. Wasn't at 0, it was at 1. Okay, it shows how hard these are. So many things to remember. I even had it written there. I just didn't graph it properly. And the weird part is that there was such a big gap between these points, like that point and that point, that I couldn't tell where, just like with my eyes, see where that should be. So that was another reason that it would be easy to miss. Okay, so this one has one other like thing in the R3s that I want to talk about. What if I just gave you clues and you had to figure out what the equation was? Remember those kind? All right. Let's say that there's a horizontal asymptote at y equals 1. There's a vertical asymptote at x equals 4. If it's a normal, meaning this graph that hasn't been stretched, then what's the equation for it? So my hint, I'd sketch it. And then I'd try to figure out, well, what would that equation have to be? It's got to be one of those fraction functions, right? I'm going to pause for a second while I give this a try. Okay, from these clues, horizontal asymptotes at 1, so that's looking like that. And that's one of the hardest things. You know that at the end, the asymptote's here, but how do you get those? It's because of that little 1,000 test. If you put in 1,000, it should come out to 1. That means it's like 1,000 over 1,000. So when you look at your equation that you write, which obviously has to be something related to 1 over x, then you have to make sure that this thing would actually come out. When you put in 1,000, it needs to come out to 1. And right now, if I put in 1,000, it would not come out to 1, right? So I have to do something different. Oh, I'd have to have an x on the top. Because see, if I put an x on the top, do you get now if I put in 1,000? It would come out to y equals 1. All right, so I'll do that again in a second. And the other part is I have to move this thing over because the vertical asymptote's at 4, so it's got to be like an asymptote there at 4. And how do I get it to move over 4 to the right? That would make it move over 4 to the right, wouldn't it? All right. Now, why can't it just be this? Why can't it just be like that? What's wrong with that equation right there? That's move 4 to the right. It wouldn't have a horizontal asymptote at 1. Now, there's 2 ways to fix it. So, do you get if I moved the whole graph up 1? That would move the asymptote up here, wouldn't it? You could add 1 to it like that. That's a way to make the asymptote go up 1. You know what I'm saying? And then if you test the horizontal asymptote and go, okay, I'm supposed to get 1 by putting in 1,000. You put in 1,000 here. You'd pretty much have 1 over 1,000, which is pretty much 0. But by adding 1, I'd have y equals 1 for my asymptote. Yay, that worked. And I'm done. If all you did was put an x on the top, I want you to see how just putting an x on the top, we got to see if that would work or not. So if I just put an x on the top, would my horizontal asymptote be at 1? Would it? If I have 1,000 here and 1,000 here? And those would cancel, but they would reduce really to 1. And so that would work. Would it still have a vertical at 4? Yeah. So that would also work. There would have been 2 right answers for this. You could either put another x on the top, or you could have added 1 at the end. Both ways would have worked. All right. That's a tricky one. And then last but not least, dividing fractions. Let's do the simplest dividing fractions of all time. If you don't remember this, then you won't possibly remember the one that's really complicated. So just remind yourself how this works. Okay, so you know that means 1/2 times 3/4, right? And then, so that's going to be 1 times 3 is 3 over 8. Raise your hand if you had 3/8. Okay, good. Now, of course the problem won't be that easy. It'll be a great big bunch of factoring that you have to do the same thing where you flip and multiply it and factor it. So here's a practice like that. X squared minus 3x minus 4 over 2x plus 10 divided by x plus 5 on the bottom and x squared minus 16 on the top. Not only do you have to flip and multiply, you also have to do some factoring and some canceling. I'll pause for a second while I give this a try. All right, first thing I do is factor all of them. 3 out of the 4 parts can be factored. So I'd factor this to, it's up. Okay, x and x, and then a minus because there's a minus in the problem. Has to be a plus. If the last number is negative, it has to be a plus and a minus. And then it has to be a 4. And I'm pretty sure it has to go there, 4 and 1. Correct me if you think I'm wrong. And then on the bottom, this will be factored into 2, x plus 5, like that. And then this divide changes into times. And then I flip this over so the x plus 5 that was on the bottom is on the top. And then this will be x plus 4 and x minus 4 down here. Then that will cancel that. That will cancel that. And I am left with, and cancel isn't probably the right word, those will reduce away. So I have x plus 1 over 2 times x plus 4, and I would leave it factored like that. And who had that one right? Raise your hand if you did. Okay, awesome. So now I'm going to recommend that I am going to post one last worksheet that has a lot of practice problems on that. And I'm going to turn it over to you now. You should do as many as you should do, as many as you need to do. And it does depend on the kid. Some of you got a straight A on this and have probably got every practice problem I just did with you right. You probably don't need to do too many. Others of you, this cumulative is huge. It's a really big deal. So you should do a bunch of practice. So I'm going to open up another review worksheet. And you can take the one you did yesterday and just like finish that. That would be a good proof you worked on stuff. And I'm going to open up that other worksheet, and some of you might need to do some of that. Okay, so kind of on you. The one thing I would ask you to do is finish up at least some more on the worksheet I gave you last night. And then there's this extra worksheet, which some of you might not need. So I'm leaving that up to you. And that's all I have for you. Everybody open that up right now, please, and get to work. And that's all I got for the video for today. If you refresh now, that extra worksheet on this is now available.